All right, we are going to look at rational equations today. And if you will notice, we have changed what we've been talking about, rational expressions, to equations. And that's because equations have equal signs. So we are going to introduce those today. So as a basis, this is kind of what we're looking at. So let's say we have 1/3 and we add it to 2/5. And I'm going to tell you that that equals 11/15. So you're looking at that and you're thinking, does it though? And the best way that we could quickly check this mathematically would be to get common denominators. So if we look really quickly, we've got a 3, a 5, and a 15. The common denominator here is definitely 15. So if we do that, and on this one, we multiplied by 5. So 1 times 5 is 5. And on this guy, we multiplied by 3. So 2 times 3 is 6. And over here, of course, we just left that. And 11 times 1 is 11. So this checks out. And the reason you know that this checks out is because this 11 is equal to 5 plus 6. So really, my point is, once we had common denominators, we didn't even look at our denominators. We just needed to know that 5 plus 6 did in fact equal 11. And that is going to be the base of everything we talk about today. That as long as we have common denominators, to solve an equation, because we're going to solve for x, as long as we have an equation, or as long as we have common denominators, we can solve the equation in the numerators. All right? So we must have common denominators. That's our whole goal. All right, so let's take a look at this. What if we start with a problem like this? This is similar to what we just did, but it looks a little more complex. 15 over x minus 6 plus 7x over x minus 6 equals 6 over x minus 6. So right now, this is similar to what we just talked about. We have common denominators. So remember, we're going to replace x with numbers eventually. And if we did that, if we replace x with 10, then this just becomes 10 minus 6, 4. So these are just values. So we have common denominators. That means we are going to take our numerators and we're going to solve for this x. So I need to know, what number does x need to be to make this statement true? So now that I have common denominators, I'm going to isolate the numerators. I'm just going to focus on my numerators. And I'm going to say 15 plus 7x equals negative 6. And now I can solve for this. So what do we know about algebra? To solve for x, our goal is to get x alone. We're going to subtract 15 from both sides. That's going to give us 7x equals negative 21. Divide by your 7, and we get x equals negative 3. Now, if I go back and want to check that work, then it would look like this. I would say 15 over x minus negative 6. Well, I just said x is negative 3. So negative 3 minus 6 plus 7 times x is negative 3, over x minus 6. Negative 3 minus 6 equals negative 6 over negative 3 minus 6. If I do this, then what am I getting here? I'm getting 15 over negative 9 plus negative 21 over negative 9 equals negative 6 over negative 9. Well, what we know about fractions is that when we add them, we don't actually add the denominators, we add the numerators. What is 15 minus 21? 15 minus 21 is, in fact, -6. So we have -6 over -9 equals -6 over -9. So it worked. We have proof that this strategy works. So let's go through those steps one more time. Step 1 is going to be get common denominators. Okay, get common denominators. Step 2, isolate numerators. Step 3, solve for x. All right, so these are our steps. Let's try another one that's a little more complex. Let's say we have 2x over 3x minus 5/6 equals 5 over 2x. I do not have common denominators here. I have a 3x, a 6, and a 2x. So the first thing we have to do is find our common denominators. So I'm going to set up my problem. What number is common? What's the common multiple of 3, 6, and 2? The answer is definitely 6. And then let's look at our variables. What variable is common in 3x, 6, and 2x? X, just one. I just need one x. So that means we need our common denominator to be 6x. So we're going to look at this and ask ourselves, 3x times what equals 6x? And we're going to need to multiply by 2. So 2x times 2 is 4x. Over here, 6 times what equals 6x? Well, we need to multiply by x, and 5 times x is 5x. Don't be scared of the variables. And in this one, 2x times what is 6x? We need to multiply by 3. So 5 times 3 is 15. So now we have common denominators. Step 1, check. Now we're going to focus solely on our numerators. So like I said, once we have common denominators, we're going to isolate our numerators. So that's going to give us 4x minus 5x equals 15. Step 2, check. Solve for x. 4x minus 5x is negative x, negative 1x equals 15. Divide out your negative 1. And what do we get? X equals negative 15. Okay, so we found our common denominators. We isolated the numerators. We solved for x. Let's try another one. Let's try 1 over 7 times x minus 3 plus 4 over 7 equals 3 over x minus 3. So now this one looks a little more difficult because this common denominator is not as obvious, but it's there. So remember, when you don't have a really blatant common multiple, our best bet is to multiply everything together. And if we look really carefully, that's kind of already done. Like the 7 and x minus 3, well, if I multiply them together, it's 7 times x minus 3. So it's already done. So this is going to be my common denominator. So I'm going to rewrite all of my denominators with my common denominator. So it's really clear and organized, and I don't lose track of what I'm doing. In this first one, did we need to multiply by anything to the common denominator? No. So I'm just going to leave my 1. In the next one, 7 multiplied by x minus 3, right? So I'm going to multiply my 4 times x minus 3. In the last one, what do we need to multiply by? We need to multiply by 7. So 3 times 7 is 21. Okay, that's the first step, common denominators. Now we're going to isolate our numerators. So we're going to have 1 plus 4 times x minus 3 equals 21. Now you can distribute this 4 right off the bat if you'd like. It won't hurt a thing, or you can divide it out. Multiple ways to do that. I'm going to go ahead and subtract my 1, because now I'm solving for x. That leaves me 4 times x minus 3 equals 20. If I divide by 4, I've got x minus 3 equals 5. Add my 3 on both sides, and I find that x equals 8. Do you see how those steps went through the same way again? We found our common denominator, even though it had a variable, that was okay. We isolated our numerator. We solved for x. We got our final answer. Let's try another one. And when I give you these problems, feel free to stop and solve them yourself and then see how you did. Okay, let's try 4 over 3x plus 12 plus 2/3 equals 2x over x plus 4. Now, this one is not as obvious. 3x plus 12, a 3, and an x plus 4. But a 3 and a 4, that equals 12, doesn't it? Can't I factor out a 3 right here and get x plus 4? And if I do that, then I've got the 3 and the 3 that's appearing, and the x plus 4 and the x plus 4. So actually, this 3x plus 12 is my least common multiple, and I can use that as a common denominator. So be careful for that. So my common denominator, and I'm going to write it in factored form so it's a little easier to see. So the key was knowing to factor there. So 3 times x plus 4, and then 3 times x plus 4. So now, same process. What did you need to multiply by here? Nothing. That was our common denominator, so we're going to leave our 4. In the second one, we needed to multiply by x plus 4. So we're going to have 2 times x plus 4. And on the right side, we needed to multiply by 3. So 2x times 3 is 6x. Now that we've got our common denominator, we're going to isolate our numerator and go ahead and solve for x. So 4 plus 2 times x plus 4 equals 6x. Now, I think in this one, I'm going to go ahead and distribute. And if I do that, I'm going to get 4 plus 2x plus 8 equals 6x. The reason I distributed was because I saw that I had a 6x here, and I've got an x here, which means I'm going to collect like terms, so it seemed like a good move. Now, if I keep going with this, I'm going to get my 4 plus 8 is 12 plus 2x equals 6x. I need to get these x's together, so I'm going to subtract a 2x on both sides, and that's going to leave me 12 equals 4x. Now I'm going to divide out my 4, and we get 3 equals So we followed the same procedures. This one was just a little trickier because we had to do some factoring to find our common denominator. So we found our common denominator, we isolated our numerator, and then we solved for x. All right, we're going to do one more. This is the most complex of them all. And again, it just has to do with finding that common denominator that looks a little trickier. So we have 3 over x minus 4 plus 2 over x plus 5 equals 12x over x squared plus x minus 20. Now, this is looking a little crazy, but what is this? It's a quadratic, and what do we know about quadratics? What's always our first move? Factor, 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 factor. And if we factor this thing, what two numbers multiply to negative 20 and add to 1? You know it. X minus 4 times x plus 5. Oh, and then you're like, ding, ding, ding. Look at this. X minus 4, x minus 4. X plus 5, x plus 5. Boom. We had a common denominator. We didn't even know it. Or, sorry, common multiple. We didn't even know it. So, same process. We're going to write this thing out again. X minus 4 times x plus 5. X minus 4 times x plus 5. It's getting long. X minus 4 times x plus 5. So, over on this one, what do we need to multiply by? We need to multiply by x plus 5. So 3 times x plus 5. In this one, we need to multiply by x minus 4. So I'm going to say 2 times x minus 4. And in the last one, everything was all good there, so we're not going to multiply by anything, and I'm just going to leave my 12x. Got my common denominators. I'm going to isolate my numerator, and that's going to give me 3 times x plus 5 plus 2 times x minus 4 equals 12x. Now, this thing is getting a little ugly, so I'm definitely going to distribute. And when I distribute my 3, I'm going to get 3x plus 15. Then I'm going to distribute my 2, and that's going to give me 2x minus 8 equals 12x. Collect like terms. We have a 3x, a 2x, and a 12x. Those all need to get together. So 3x plus 2x is 5x. So I'm going to go ahead and I am going to subtract 5x from both sides. Also, in one step, because we're at that level, 15 minus 8 is 7. So I'm going to do 2 steps in one here. So that leaves me a 7 on this side, and over here, 12x minus 5x is 7x. Now, if I divide both sides by 7, I get 7 divided by 7 is 1 equals x. So again, we followed the same steps every time. We found our common denominator. We isolated the numerator, and then we solved for x. What made this problem a little more complex was that we had to factor a trinomial to find our common denominator. We had to distribute, which is fine, we can do that. Then when we solved for like terms, we had to collect like terms and do some rearranging, but that algebra should be very manageable by now. At the end of all these problems, you can take this number you found and plug it back in. Plug that 1 in into all these x's, and you should get identical, you should get an even solution. In fact, should we do that real quick? If I go back in, I'm going to check my work. And I'm going to plug in x equals 1 to all of this. And I'm going to get 3 over 1 minus 4 plus 2 over 1 plus 5 equals 12 times 1 over 1 squared plus 1 minus 20. So this equals 3 over negative 3 plus 2 over 6 equals 12 over 22. Nope, can't do that. 2 minus 20 is negative 18. Okay, these don't have common denominators, but I can get them real quick. And if I do that, and my common denominator is negative 18, then on this one I multiplied by 6, and 3 times 6 is 18. And on this one we multiplied by negative 3, 2 times negative 3, negative 6. And over here we've got a 12. Well, isn't 18 minus 6 12? So we've got 12 over negative 18 equals 12 over negative 18. And it all checks out. Okay, cool, we're done.